Hello everybody, and welcome to today's lesson. We're going to be actually talking about some applications of integration and how we can calculate consumer and supply surplus. Okay, so as most of you know, my degree is in engineering. I'm not a business major or economist, so I'm going to do my best to explain these terms and how you can use the calculus to do that. Okay, so when we're talking about consumer surplus, conceptually, that is a measure of how much consumers derive a benefit from an economy when prices are low. Okay, so the more competition you have, generally, the lower the prices. But you also have to understand that price and quantity are inversely related, because as a price goes up, the lower number of units are going to be sold, right? And the lower the price, the more we're going to sell. Now, that has other implications, because if you take the price too low, then you're going to actually flood the market and everybody's going to buy, and then there won't be any more demand. Okay, so those are the kinds of things that business people are looking at and taking into account. So we're going to have a demand function that we have to look at, and what it is designed to express is how price and quantity interact for a product. Okay, so we may have a curve that looks like this, okay? And then this here would be called my demand curve, all right? And they use d of x. No, this is not dx, this is d of x. And what they're showing here is basically, as the price of an object increases, we're going to sell fewer and fewer units, right? Because the units along the x-axis is quantity, so it's shrinking as price is going up. Conversely, as we drop the price, the more units we're going to sell. But there again, there's another aspect to that you have to take into account. At what point do you flood the market? But that's beyond this discussion. So the demand function is going to tell us the price at exactly which X units are sold, all right? Now, what comes into this is the market price, okay? And that's the value that the consumers are actually paying for an object, okay? And that can fluctuate, right, as the economy changes. But this benefit, this consumer surplus that I was talking about, is going to be this area up in here, and we will assume that maybe instead of this demand curve just going to infinity, that maybe it intersects here along the y-axis with price, okay? So we're able to calculate an area, obviously, from 0 up into some value A, which is going to be known as the demand quantity, okay? So when we're looking to calculate consumer surplus, we are going to have an equation, and this market price they're going to call B, okay? And we're going to integrate the demand curve minus the market price dx from 0 to A, okay? So obviously, let's go from here to this demand level. We're going to integrate the demand curve from the market price. So if you'll notice, this market price is just a horizontal line, right? So that's how we can use that. Just like we were talking about in previous lectures, we can find area between two curves by integrating the upper curve and subtracting the lower function in this case, okay? So let's look at an example. So utility companies that produce electricity. This particular one has a demand function of d of x is equal to 1100 minus 10x dollars, okay? So, and then x is in millions of kilowatts per hours, and then they'll put a restriction on the domain here of x is 0 to 100. So they want to know the consumer surplus at the demand level, x is equal to 80. Okay, so this value right here is actually your A. Okay, so how do we go about doing that? Well, we're going to integrate from 0 to 80 my function 1100 minus 10x, that's my d of x, and then I'm going to subtract my market price value here, which in this particular case was 300, okay? So let me get our graph up here so you can see where that 300 comes in. So I'm looking at up to 1100, and I've got this line that is given. So here is my 80, and then they've gone in and decided that the market price is 300, okay? So how did we find that though? Well, in order to find that, we had to take the value of 80 and actually put it in my demand function, okay? So d of 80, this is how we're going to find this value, was equal to 1100 minus 10 times 80, okay? Or 1100 minus 800, or my 300, okay? So I determined that market price value based on this demand level. And that makes sense for any function, right? The x value into the function should produce my y value. So here's where I get my 300 on my graph. So what am I looking for? I'm looking for this area here if I'm talking about surplus, right? So that leaves me with an integral from 0 to 80 of, what, 800 minus 10x dx. So when I integrate that, I'm going to get 800x minus, now here my n is 1, right? So 10 over 1 plus 1 times x to the 1 plus 1, all from 0 to 80. Okay, so let's simplify that. So I have 800x minus 5x squared from 0 to 80, okay? Now, if you'll notice, this lower bound is 0, and everything inside of my result has an X. So I'm going to actually be subtracting nothing, right? So I'll have 800 times 80 minus 5 times 80 squared. And again, that's my upper limit. Normally I would have subtracting a value from the lower, but when I plug that in, I see I'm going to get 0. So there's no reason to write any of that down. So I'm going to have 64,000 minus 32,000, right? Or a final answer of $32,000, right? So that is a measure of the consumer surplus for this particular example. So the key is take your value, the demand level, plug it into your demand function to get that price, okay? Because this has to coincide, right? And then I can take the integral between the upper function and the lower to find my demand or a consumer surplus, okay? So if the consumers can have a surplus, so can the suppliers, okay? So when we're talking about supply, we're going to typically have a function that's going to look like this. Price, quantity, and here is my supply curve. Okay? And the supply function S of X for my curve here, right? S of X is going to tell me exactly the price at which X units will be supplied, okay? So here, when we start talking about the market price, again, it's going to be market price, and we're going to use B. Here, when we start talking about the producer's surplus, we're going to be looking at the area here, okay? So if you think about that now, the integration formula for this is going to have to be from 0 to A, and of course, out here is my A, right? So from 0 to A of the market price minus the supply function, okay, dx. So kind of an opposite, if you will, from the consumer, which makes sense, right? What's good for the consumer may not be good for the supplier and vice versa. So let's look at an example. Let's say that we have a supply function, S of X, that is given at 0.09 X squared dollars. And we know we have a demand level of 200, okay? So let's find the producer's surplus. So first thing I'm going to do is I'm going to take my 200 and I'm going to find my market price, all right? So S of 200 is 0.09 times 200 squared. And when I put that into my calculator, I get a number of 3,600, okay? So if I'm looking at my graph here, my graph now looks something like this. Out here is my demand level, and when I come up on this point, this needs to be 3,600. okay? So what am I looking for? I'm looking for this area right here, and this will be my producers surplus. And now I'm ready to go in and do my integration, right? So I'm going to integrate from 0 to 200. Remember, thinking along, I'm still moving along the x-axis, right? Don't get confused and think it's 0 to 36 because you're integrating with respect to your x. So I'm going to go from 0 to 200 for my market price B, right? 3,600 minus my supply function, which is here. So 0.09 x squared dx. Okay? Now, I don't have any simplification here on this one, so I can just go ahead and do the integration. So I'm going to get 3,600x minus, now, n is 2, right? So I'll get 0.09 over 2 plus 1, x to the 2 plus 1, all from 0 to 200, okay? So I need to simplify that. So 3,600x minus, now this is 0.09 divided by 3, so I'm going to get 0.03 x cubed, right? From 0 to 200. So again, I have this nice situation where my lower bound is 0. So when I subtract the lower bound, I'm going to be subtracting 0, aren't I? So I'm going to say 3,600 times 200 minus 0.03 times 200 cubed. And again, my lower bound is just going to be subtracting 0, so I'm not going to have anything there, okay? So punch all of that into my calculator. I'm going to get 720,000 minus 240,000 for a producer surplus of 480,000. And of course, this was in dollars, okay? So those are just a couple of applications we can use with integration, dealing with a couple of equations, formulas, whatever you want to call them, that are specific to the business world, okay? So we got to keep in mind what supply and demand and these surpluses. So again, the integration is always looking at the area of the upper function, subtracting the lower function, right? The upper function and subtracting the lower function, okay? So all you're doing is making a slight interpretation and putting it into the integration process that you're already familiar with, okay? Well, that concludes this lesson, and I'll look forward to seeing you next time.